In today's class, we are doing polynomials and we'll look at cases where we find zeros of a polynomial and its geometric meaning. Okay. So we need to understand this over here, that as the value of x changes in the x-axis, what happens is the value of y also changes, because y is equals to a function of x. What does this mean is that y is equals to say 2x plus 3 or x square plus 5, so x square plus 7. So y is basically dependent upon x. So with changing values of x, what happens is the values of y changes. So how do we get a zero of a polynomial? Zero of a polynomial is basically the value of x for which y equals to 0. So the value of x where y equals to 0 will be the zero of a polynomial. So the number of times at x-axis, the number of times this graph cuts or touches the x-axis is called the number of zeros. So here number of zeros simply will be equals to 1, 2, 3, 4, because 4 times it cuts or touches the x-axis. Say example 2. Say we have a straight line like this. So only at one point this cuts the x-axis. So therefore number of zeros equals to 1. Example 3. Say we have a graph like this, then this graph, so 1, 2, here this is touching the x-axis, so 3 points, and with this 4 points. So number of zeros is equals to 4. So the number of times the graph either touches or cuts the x-axis is called the number of zeros. Okay. So now we begin with the next topic, that is a relationship between coefficients and zeros of a polynomial. So first of all, we are going to work it for a linear polynomial. For a linear polynomial, say p of x equals to, say a general way of writing a linear polynomial is ax plus b. So this implies if we need to find the zero of a polynomial, we take p of x equals to 0. So this implies ax plus b equals to 0, which implies x equals to minus b by a. So minus b by a is basically the zero of a polynomial, and this is equals to the constant term, negative of the constant term, by the coefficient of x. So which is equals to minus of constant term divided by the coefficient of x. So this is for a linear polynomial. Next, we take a quadratic polynomial. For a quadratic polynomial, p of x looks like ax square plus bx plus c. So this implies p of x equals to 0 will imply ax square plus bx plus c will be equals to 0. So a comes common, we have x square plus b by ax plus c by a equals to 0, which implies x square plus b by a x plus c by a equals to 0. So why we are taking a common is because we are trying to make the coefficient of x square as 1. On taking a common, here we had a, so a comes common. Here we didn't have a. Whenever we take common something which is not present, what we have to do is we have to divide, because a into x square becomes ax square, a into b by ax will become bx. So that is why we take in division when a number is not present. So this is our equation. Now let alpha comma beta be the roots of p of x. Then x minus alpha will be a factor and x minus beta are factors of p of x. Or we can also say that x minus alpha into x minus beta will be equals to 0, and this should match with the polynomial that we have. So this becomes x square minus alpha x minus beta x minus minus plus alpha beta equals to 0, which implies x comes common, x minus alpha minus beta comes common, so this implies x square minus, over here x comes common, we have alpha plus beta plus alpha beta equals to 0. Now let's take this as equation 1 and let's take this as equation 2. Where alpha and beta are the roots, what we get the quadratic equation as is x square minus alpha plus beta into x plus alpha beta equals to 0, and the main equation that we had, on solving it, what we get is x square plus b by ax plus c by a equals to 0. So their coefficient should match. The coefficient of x square is 1, the coefficient of x square is 1. That is why we made the coefficient of x square 1 over here, because we need to match the coefficients. So therefore what will happen is minus of alpha plus beta, the coefficient of x here should be equals to the coefficient of x here equals to b by a, from 1 and 2. So this should be there, the coefficient of x should be equal. So this implies alpha plus beta equals to minus b by a, and the constant term must be equal. So alpha beta should be equals to c by a. So these two are the main objective of doing this one, that the sum of the roots will be equals to minus b by a and the products of roots will be equals to c by a, or sum of roots, or we can write this as zeros as well. Roots or zeros basically means the same thing. So say we write sum of zeros equals to minus, this is coefficient of x, is the coefficient of xb, and a is the coefficient of x square, by coefficient of x square. And the product of zeros is equals to, c is the constant term divided by a is the coefficient of x square. Okay. Example. Find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and the coefficients. So solution. So what is given to us? X square plus 7x plus 10. So that is, after middle term breaking, we have 5 plus 2. 5 into 2 is 10 and 5 plus 2 we get 7, x plus 10. So x square plus 5x plus 2x plus 10. In the first two x comes common, x plus 5. Next to 2 comes common, x plus 5. So x plus 2, x plus 5. So x square plus 7x plus 10 equals to 0 implies that x plus 2 into x plus 5 equals to 0, which implies either x plus 2 equals to 0 or x plus 5 equals to 0. So we get either x equals to minus 2 or x equals to minus 5. So therefore the zeros of x square plus 7x plus 10 are minus 2 and minus 5. So now what we will check is that the sum of zeros, that is minus 2 plus minus 5, which is equals to minus 7, is equals to basically minus 7 is basically what? Our coefficient of x minus of the coefficient of x by 1. 1 is basically the coefficient of x square. So sum of zeros verified. Now product of zeros is equals to minus 2 into minus 5, that is 10, and 10 is basically constant term. 10 we can write as 10 by 1. 1 is basically the coefficient of x square. So this is how we verify. Okay. Next type of question that we are going to get will be find a polynomial or find a quadratic polynomial the sum and product of whose zeros are minus 3 and 2 respectively. So solution: let the quadratic polynomial B, let's take the quadratic polynomial in standard form, that is ax square plus bx plus c, and its zeros be alpha and beta. So sum of zeros, that is alpha plus beta, will be equals to sum of zeros. What is given to us is minus 3, that is basically minus b by a, and the product of zeros, are minus 2, that is will be equals to c by a. So this minus 3 is basically minus 3 by 1, and this we can write as c by 1. So a is basically 1. So therefore, if a equals to 1, b equals to c, minus 3 is equals to minus b. So b will be equals to 3 and c equals to 2. So the quadratic polynomial is x square plus 3x plus 2. So this is our quadratic polynomial. Now we saw about linear, we saw about quadratic. Now we'll see about a cubic polynomial. Say a cubic polynomial is p of x equals to ax cube plus bx square plus cx plus d. So let this have 3 roots. Let alpha comma beta. So a cubic polynomial, since degree is 3, there should be 3 zeros. Let alpha comma beta comma gamma be zeros of p of x. So therefore p of x equals to 0 implies ax cube plus bx square plus cx plus d equals to 0. So again we'll make the quotient of the highest degree as 1. So we are taking a common. X cube plus b by ax square plus c by ax plus d by a equals to 0, which implies x cube plus b by ax square plus c by ax plus d by a equals to 0. Now as alpha comma beta comma gamma are zeros of p of x, so x minus alpha comma x minus beta comma x minus gamma are factors of p of x. So therefore x minus alpha into x minus beta into x minus gamma equals to 0 also represents the polynomial. So this implies x cube minus alpha beta x. Okay, to get x square minus alpha x square minus beta x square minus gamma x into x square minus alpha into minus beta is plus alpha beta into x. Similarly, plus beta gamma x plus gamma alpha minus into minus plus gamma alpha x plus alpha beta gamma, not plus, so minus into minus plus into minus minus alpha beta gamma equals to 0. So we get x cube minus alpha plus beta plus gamma into x square plus alpha beta plus beta gamma plus gamma alpha into x minus alpha beta gamma equals to 0. This equation 1, this equation 2. So comparing 1 and 2, we get, so the quotient of x cube is same, so the quotient of x square should be equal, that is minus of alpha plus beta plus gamma equals to b by a. Alpha beta plus beta gamma plus gamma alpha should be equals to c by a, and alpha minus of alpha beta gamma equals to d by a. So this implies alpha plus beta plus gamma equals to b by a. This is 1. Another, this remains same, alpha beta plus beta gamma plus gamma alpha equals to c by a, the second equation. And the third equation will become alpha beta gamma equals to minus d by a. So this will be our relation for cubic polynomial. So example, verify that 3 comma minus 1 comma minus 1 by 3 are the zeros of the cubic polynomial p of x equals to 3x cubed minus 5x square minus 11x minus 3, and then verify the relationship between the zeros and coefficients. Solution. So p of x given to us is 3x cubed minus 5x squared minus 11x minus 3. We need to check one by one if this is 0 or not. So p of 3 equals to 3 into 3 cubed minus 5 into 3 squared minus 11 into 3 minus 3. So 3 cubed is 27, 27 into 3, 81, 3 square 9, 9 5, 45, minus 11 3, 33, minus 3. So we have, this is 36, 36 and 45 we have 81. So 81 minus 81, 0. Now p of second is minus 1 equals to 3 into minus 1 cube minus 5 into minus 1 square minus 11 into minus 1 plus 3. So minus 1 cube minus 3 minus 1 square plus, so plus into minus, minus 5 minus minus plus 11 plus 3. This was supposed to be minus, the equation is minus. So this is minus 3. So minus 3 minus 5 minus 8 minus 8 minus 3 minus 11. So 11 minus 11 we get 0. Now p of minus 1 by 3 is 3 into minus 1 by 3 whole cube minus 5 into minus 1 by 3 whole square minus 11 into minus 1 by 3 minus 3. So we get negative cube is negative. So 3 by 3 cube minus square positive, positive into negative, again negative, 5 by 3 square, negative into positive, negative is positive, 11 by 3 and minus 3. So this is 3 square, so minus 1 minus 5 is minus 6 by 3 square is 9 plus 11 by 3 minus 3. LCM 9 minus 6 plus 3 3s are 11 3 33, and this is 1 1 9s are 9 3s are 27 minus 27. So 33 minus 25 minus 6 is minus 33 by 9. So this we have as 0. So therefore 3 comma minus 1 comma minus 1 by 3 are the zeros of p of x. Now comparing the given polynomial with ax cube plus bx square plus cx plus d. What we get is a equals to the quotient of x cube. So 3 minus 5 minus 11 minus 3. 3 minus 5 minus 11 minus 3. So b is minus 5, c is minus 11, and d is minus 3. So we get the values of a, b, c, d as this, and let alpha, we take the zeros as alpha, beta and gamma. Alpha is 3, beta is minus 1 and gamma is minus 1 by 3. So therefore alpha plus beta plus gamma is 3 minus 1 minus 1 by 3. That is equals to 3 minus 1 is 2, 2 minus 1 by 3 is 5 by 3, which we can write as minus of minus 5 by 3, since we need to show as minus of, this is b by a. Alpha beta plus beta gamma plus gamma alpha equals to alpha beta is minus 3 plus beta gamma is 1 by 3 plus gamma alpha. Gamma into alpha plus into minus will become minus 3 into 1 by 3 is 1. So minus 3 minus 1 is minus 5, minus 4 plus 1 by 3. So minus 4 is basically minus 12 by 3. So this becomes minus 11 by 3. So this is equals to c by a. And alpha beta gamma is equals to 3 into minus 1 into minus 1 by 3. This cancels off. We have a 1. 1 we can also write as 3 by 3. And we can write this as minus of minus 3 by 3. So the value of this is also 1. Minus into minus is plus. 3 by 3 we get 1. So we are supposed to get 1, and in this way also we are getting 1. And in this way what is happening is we are getting this as minus of, this is basically d by a is 3. So minus d by a. So hence our work is done. So with this we come to end of today's lecture. Thank you.